we have a lot to go through between today and tomorrow. So, I mean, like, I kind of feel like I'm at the point where I want to relax a little bit so you guys can just get things done. But at the same time, we can't. And that's Calc in a nutshell. That's all year. They're just, everything takes so long. So if you look at this section, it's a lot of pages. Like, a lot of pages. Just every single time you think it's going to end, it keeps going, and then there's a new topic, and then, I don't know, it's like 10 pages or something, you said? Yeah. It's much longer than it feels like you're expecting. And I kind of get why. At the same time, well, I don't know why they just didn't make it another section, but hey. But yes, this is my favorite story problem of the year. The beginning of this section is on interpreting derivative in context to real world scenarios, which, if I remember correctly, has nothing to do with my favorite problem. So like, oh yeah, it starts off with this, just like, what is this trying to tell us type thing. So there's a whole problem up here that I'm going to skip and go down to my favorite one. Now I'll give you guys a minute to read it. And then maybe you can figure out why it's my favorite problem. I'm trying to decide if the lady that wrote this is a moon denier. Like, the first couple times I did this problem, I didn't even catch that wording. First it says, did Neil Armstrong step off the lunar module and pick up a moon rock from the surface of the moon? If he did, as soon as I realized what was written, kind of makes me question a lot of things in this packet, but I'm pretty sure she put it in there as a joke. But it still got me a little concerned, and I distinctly remember this problem from all of the packets, because I didn't even catch this the first time, and then all of a sudden I was teaching class one day, and then I realized it said, if he stepped off. Look, he definitely did. So I don't know what to think about it, but hey, that's what makes it my favorite problem. Nothing to do with the math, okay? The math part is fine, that's normal. It's the fact that I don't know if this lady actually believes we landed on the moon or not. Even though we know a lot of things, like we could design the spaceship to get to the moon, but I don't know if she believes we went there. Okay, actual number problem here, right? Scientists say the rock would have a velocity of 24 meters per second. Okay. The height of the moon rock can be modeled by the function in seconds. So it also doesn't mention this, but it is most definitely talking about throwing the rock. Like, it actually just talks about picking up the rock, and it never actually mentions what you're doing with it. So to have an initial velocity of 24 meters per second, that would mean you have to have thrown it. He's not going to pick it up and it's just going to take off at 24 on its own. So that function represents the height of the rock. Find the velocity and acceleration of the moon rock as a function of time. Now, this question is kind of like a precursor to this section, because I showed you guys it yesterday in the notes, but it hasn't been talked about yet really fully. We're getting questions about velocity and acceleration, but we were only given the position function. So this implies we should be able to figure them out. And so it's definitely going to be part of our everything, that we're going to automatically know, I don't even know where to put this, maybe I'll put it over there. We're gonna automatically be able to figure out all of them if we are given position. And then this is a little bit later in the section. I'm not entirely sure why they picked the notation that they did. S of t is traditionally for distance. Don't know why it's an S, but in Calc, they will traditionally use S of t as vertical distance. If it's represented by horizontal distance, they often write it as x of t. So there's a lot of strain. I'm sure there's a reason for the S. I'm sure it's because it's in like Latin or something like that, you know, whatever that is. S of t was 24t minus 0.8 t squared. Okay, velocity is going to be the derivative of position. So 24 minus 1.6 t. And then acceleration would be negative 1.6 ohms. Now I believe this was all meters, meters and seconds. So this is supposed to be the acceleration due to gravity on the moon. On Earth, it's negative 9.8. And which kind of makes sense because, I mean, the moon doesn't have nearly as much gravity as Earth. All right, so now we'll go back to the actual questions. I basically just do that right away so I can like not worry about that while I'm doing the problems. So let's find the velocity and acceleration of the moon rock as they okay, well that was question 1, was to write those equations. Rather than rewrite them, fine, that was part A. How long will it take for the rock to reach a maximum height? Okay, now this particular section, you don't have to have taken physics, you don't need to be in physics, but they kind of incorporated into Calc a lot, for better or for worse. They do. To me, this absolutely feels more like a physics-ish question. The only thing we know about maximum height is that, like, let's say you throw something up in the air, it's going up, and then for a brief second it stops, and then comes back down. We know it's symmetric between up and down, but the fact is at the very top, when it stops for a brief second, the word stops is what we can use to help us solve it. So this means velocity is 0. And so I know some of you already know this. I know some of you have taken nothing like physics. So a lot of these questions, I kind of want to treat them as if you've never seen them, because I know some of you haven't, some of you have. Okay, so reaching a maximum height means the rock stops for a brief second, so the velocity is 0. So when we are asked to find when it will reach a maximum height, we're going to take the velocity equation, which is 24 minus 1.6 t, and figure out when that equals 0. So I have no idea what this is. What's 24 divided by 1.6? 15. Oh, wow, that's a nice easy answer. I don't know, should I call on somebody? Onyx, who should I call on?
I can try to do it.
What does 15 stand for?
The seconds.
Perfect. This is telling us it takes 15 seconds for the moon rock to reach the maximum to start coming back down. Now, this question is partially here, because for some reason on the AP exam, they have these questions frequently, almost exactly like this. It'll ask you when it reaches a maximum height. Okay, well, we just talked about the very top. Apparently that's at 15-second mark. Then it's going to ask you, what is the actual maximum height? Well, we have to take this answer and use that to find the actual maximum height. So then we would do the height function at 15 seconds. And we're only using 15 because we just figured out that's the maximum height. Now these problems may actually sound familiar from Algebra 2. Do you guys ever remember doing these in Algebra 2? When we first learned quadratics, you guys learned how to find the vertex of a quadratic with negative b over 2a? Does that faintly sound familiar? That would work on this as well. If I did negative b over 2a, I would get x equals 15. So there's overlap, and there's actually probably going to be multiple ways to find things. I'm bringing this up because the obvious goal for our class is that you are supposed to use derivatives. So when you guys get questions that can be solved with a different method from a different class, I get it, but I need you to use the calc method because that's the whole point of what I'm trying to check for. So use the other way to check your answers or something, I don't care, but I need you to do it the calc way just because. And you're going to get plenty of questions when that happens. Okay, so this is the first answer. I don't actually care what it is. You can just type it in a calculator. When did it hit the ground? We had this yesterday from that, what was it, the potato gun. Do you remember what hitting the ground is code wording for? The height is 0. I should change the color, there's way too much going on here. Hitting the ground is going to be code wording for height of 0. And where that will be important is the height function is s of t. I'm going to set that equal to 0 to find the time it hit the ground at. And again, you're just going to have to go through the work to solve it. It's going to be a lot of algebra work here for these types of problems. But I didn't want to focus on this too much today because this section has just a crazy range of things we cover. It's all dealing with position, velocity, and acceleration for half of it. Do you want me to raise it up? It's like hard to see the bottom. Okay. Wait. Yeah. Okay. A good portion of this section is going to be on position, velocity, acceleration. So the main thing you need to get in your head: position, derivative, velocity, derivative, acceleration. There is a portion of this section that's on interpreting things. Well, it kind of goes hand in hand with story problems, and we're doing that before we get to the next unit because the next unit has a bunch of story problems sections. Okay. I don't know how comfortable you feel with this topic. Is this something that, like, you feel I should go over with you? Interpreting notation? I kind of have to leave it up to you because I know how to read it. I just don't know if you do or not. Go over it? Okay, you guys have to learn to answer for yourself. Like, I know what I know. I don't know what you know. Okay. Up here, suppose W of X is the daily quantity of water in gallons, okay, required by a palm tree of height X feet. All right, so the amount of water X feet tall. Explain the meaning of each expression in a complete sentence, including units. Oh, okay. What did it tell us X represented? Height. Okay. So the number in the parentheses is X. So that tells us the height of the tree. Water needed. Let's pretend I can spell needed. Is 38 gallons. The amount of water needed for a 25-foot tall tree is 38 gallons. Does it say this is daily? Yeah, daily. Okay, maybe you should not grow that palm tree if it needs 38 gallons just to live. I will be super nice to you and skip this one because the inverse information will break your brain currently. I know you guys have done inverses before, but I can tell you over the years of trying to do this with students, this absolutely kills them. Like working your brain in reverse, it just doesn't work right. So I will hold off on that one until we get to derivative of an inverse to talk about inverses. So let's talk about the W prime, because that's more what we're focused on right now. What? Darn it, 25-foot tree. X is still the same. What does that stand for? Oh, I thought you were trying to guess something. Anybody have a guess? Okay. Prime represents derivative. Derivative stands for slope. Slope stands for how fast something is changing. So the amount of water needed for a 25-foot tree is changing at a rate of 6 gallons per day. Now, so this might mean you needed 6 gallons more than the previous day. It might mean it needs 6 gallons more than the 24th tree. This just means it's currently changing at 6. Okay? I don't know if I'll write the whole sentence out though. I should have put per day up here because when it said daily quantity needed, that means 38 gallons per day. When you take the derivative, you are basically trying to compare it to another day. So anytime you take the derivative, you add more information on it. Like, think of distance, right? Distance is feet. Velocity is the derivative. Velocity is going to be feet per second. So we added the per second. What's the label on acceleration? You remember? It's feet per second squared. Feet per second squared means feet per second per second. Every time you take the derivative, you're going to add onto the label. And you're going to add on whatever the whatever the units are, I guess I should say. I'm trying to think of a better way to phrase that. But basically what we are measuring.
So same change at 6 gallons per day.
6 gallons per day more than the previous day. Okay, I don't wanna do this too much because honestly, I could spend an entire day talking about just labels, and that's not a bad thing. But just in terms of how much information we have to cover, I don't want you to have to cover and learn the rest of the information by yourself. So I wanna make sure to try to cover all sorts of topics. No. Shoot. There's no problems to do on this page, but I want to talk about the topic. Particle motion is going to be a specific type of problem you're asked about. And it's position, velocity, acceleration, but it's not like a regular one that you've really ever done. Particle motion is going to be if you have a single number line. So basically think of an XY axis, but only horizontally. You don't care about the height. And then you're going to have a particle, okay. You're going to have a particle that moves back and forth along this number line. So they refer to it as particle motion. The equation you're going to be given tells you the distance away from zero the particle is at any given time. So it might go slow. What the heck? It might go slow. Why can't I? Okay. I like how it's not even on my finger. What is the deal here? That should not be the case. This is a computer. It is supposed to follow correct programming. Okay. It might go slower one direction, faster another. That will all be stuff we figure out with the equations we're given. If a particle is moving to the left, would its velocity, oh, actually no, let's talk about position and velocity acceleration separately. Position, on the right hand side, this would be a positive position because it matches up with the number line. This would be a negative position because it matches up with the number line. So that's position, that should be straightforward. Velocity tells you how fast it's moving or changing. A positive velocity would mean it's moving to the right. It doesn't actually matter where it starts from. A positive velocity just means moves to the right. A negative velocity moves to the left no matter where it starts from. I'm trying to think of how to phrase acceleration. A positive acceleration is a push to the right. Okay? Like an imaginary push. If your particle is moving to the right, and I push it to the right, it will move to the right faster. So, positive velocity and positive acceleration would speed it up. If your particle is moving to the left, a push to the right would slow it down. So I'll say those words also again, slow it down. because that's actually gonna be important. Annoying, but it's important. If your particle is moving to the left, a negative acceleration is a push to the left. So if it's moving to the left and it gets pushed, it will move to the left even faster. It speeds up to the left. If your particle is moving to the right and it gets pushed to the left, it will still be moving to the right, but slower. And that's how we're going to use acceleration on particle movement. Particle movement technically is the same as free fall, but you guys can visualize in your head very different. Okay, so, come on. Nope. I'm gonna go here first. Here. Speeding up and slowing down is a very common, and I would say you're gonna get it at least 2 to 3 times on the AP test. And out of 45 questions, that's a lot. So they make a big deal out of it. I don't know why. To me, again, like to me, this is more of a physics topic, but they incorporated it into AP. So, if your velocity and your acceleration are the same, both positive or both negative, that will be speeding up. I don't know why it says increasing over there. You're going to use the term speeding up, and that's the term that will be on the AP test. They will ask you, is the particle speeding up or slowing down? And you have to know what to look for. So, if your velocity and acceleration are opposing each other, it will slow it down. That's what this chart is trying to show. Same symbols, speeds up. Opposite slows down. I hope I'm not just flying through this too fast. I don't know if it's confusing to you or not. Like I said, I have a feeling some of you already get this and some of you don't. It is a topic in calc that's hard to teach because of that. What time do we get done? I should probably stop here because I'm probably shoving in too much information already. I purposely want you to start some of these questions in here because I want you to be able to ask questions. Yeah, the homework isn't for like 6 more pages. The notes just go on forever. That's why I was trying to get through a lot of notes. It's not that any of these topics is not important, they're just, it's like so many. The main topics I would like you to try out of the homework while you're in here, because I don't even remember which numbers they are, is the topic asking you to figure out if a particle is moving to the right or left, if a particle is stopping, if a particle is speeding up and slowing down. You should have a section on particle movement questions in the homework. You also can try the ones that are asking you about labels or things like that too. But if you get a question on a graph, don't do that yet. That's tomorrow. Tomorrow is all about the graphs, and that takes a while to cover too. So basically at this point, we're just going to be rushing to get the test by Wednesday. Which unfortunately we have to do because we have to be able to get another test in before the end of the trial. For your purposes, because you guys traditionally like having the test in is pretty great. I mean, worst case scenario, we won't, but most of you like that to be able to work with the grades.